Hello everyone. Thanks for coming here. Now it's around 3 o'clock, so we're gonna wait for another 5 minutes to start these sessions. So this session will start at 3:05, and please be ready to listen this session. And I'm going to start this one at 3:05. Everyone, I'm going to start this session in 3 minutes. So this session will start at 3:05. Hello everyone. I feel like no, I feel like now I can start these sessions. Although it's a 3:03, I feel like more people will not come here. So I will start today's sessions. And before I just start, I just wanna do a quick sound check. So if anyone can hear my voice, could you guys please type anything on your chat box or click the raise hand icon on your dialog box. All right. Uh, okay, let me start these sessions. My name is Lucas Park. I'm a CAE consultant. I'm here to support our clients, MIDAS users, and also I'm doing the consulting service for the modeling part and design part as well. Today we are going to go over the steel composite girder bridge, and this one is one of the series from the 2016 MIDAS Complex Bridge Test Drive event. So last week we go over the high-speed railroad and segmented bridge. So that is on our website. If you guys are wondering how it did go, please review the recorded video. But today we are going to go over the steel composite girder bridge. And the day after tomorrow, I'm going to go over the cable stay bridge analysis. And next day, I'm going to go over the suspension bridge analysis as well. So this week, we have, including today's sessions, we have a 3 webinar. And next week, I'm going to go over the a bridge model, which is a tutorial-based modeling. So we are going to, provide a distribute tutorial to you guys. And I'm going to go over how to model this one and how to extract the result values next week, maybe Monday or Tuesday. Our invitation letter will, send out today. And then plus, I got many questions about the multi-curve options in our widget. So how you can utilize the multi-curve options in steel composite girder bridge widget. So next week I'm going to go over the one like a skew and curved bridge modeling part and result values, and then I'm going to go over the multi-curve option, how you can utilize what those terms mean and those kind of things. So always, before I start, I need to introduce who you are as a MIDAS. I think like half of you guys are from our MIDAS users and half of you guys just a beginner, or like it's been a first time to come to our webinar. So we are MIDAS. We have over 500 engineers throughout the world, and now I'm located in New York. Like a New York office, and we came over to the U.S. around 2005, and it's been around 10 years, and we are supporting we are doing the marketing and also technical support for our clients. So we have 8 different branch offices throughout the world, and now I'm in the USA. I'm we are doing the marketing and technical support for the North America and South America. So you guys are the probably most of them are structural engineer, and you might heard of MIDAS Civil a lot, or you're using MIDAS Civil. And we have other programs such as similar with the MIDAS Civil, MIDAS FEA. This one is for the advanced nonlinear and detailed analysis system. And we have one more like a program for the structural engineers, which is a MIDAS Gen. This is for building purpose. And for the geotechnical engineers, we have a 2 program which has which are GTS NX and SolidWorks. And for the mechanical engineers, we have a MIDAS NFX. These are the partial list of our users. We have many users for MIDAS Civil. and these are the partial list. Our clients are from the big firms to local firms, and we have around 30 DOTs have used our program. And what is the MIDAS Civil is a very focused on the bridge, from the modeling to design and load rating, but also we do the general structure such as tunnel and other like a general structure such as you can model the building in MIDAS Civil as well. Because we are starting from the finite element analysis tool, so you can create a model freely, whatever it is. But today I'm going to very focus on the steel composite girder bridge options and functions and modules, and also the key value of the MIDAS Civil is you can model the superstructure and substructure and solid property at the same time, and you can get the result values from there. So today we are going to go over the steel plate girder bridge, and like last week I did a segmental bridge, and this week I'm going to go over the cable stay bridge and a suspension bridge as well. Those are the few project example in the US, and you probably heard of one of those examples. And you can see like one of our clients, he modeled a cable stay bridge and a suspension bridge by using the MIDAS Civil. And this week like Wednesday, I'm going to demonstrate how easily you can model the cable stay bridge and how you can optimize your cable pre-tension forces through the MIDAS Civil. So please join our webinar about the cable stay bridge and a suspension bridge. So overview today, like I said, I just segmented some more part. The first part is a modeling part. So you guys know we have a wizard, steel composite girder bridge wizard, and I will explain how you can use wizard part. So for the this webinar is not just for the beginner. This webinar is for the people who is intermediate level or advanced level, because I collect some of the questions from the technical support team, and I'm going to point out what questions, and I'm going to give you answers. And also AutoCAD or MicroStation, you can create a bridge model. You can import the lines from the drawing program, and you can create a bridge model. And for the analysis part, I'm going to go over the result values such as moment, shear, stress, deflection, and reaction values. And also after create a load combinations per H to LRFD, I'm going to go over the design check parameter, and you can get the Excel report. So, you know, like a general, like a process in MIDAS Civil when you do the steel plate girder bridge. So first of all, you can do the modeling. You have to do like a moderate bridge. So we provide a different tools such as widget, or if you're like long-time MIDAS users, you can use a node and element, and you can get help from the drawing program such as AutoCAD or MicroStation. And in the widget, as you can see, you can create a different like modeling types. You can just model a whole bridge with a plate element, or like a frame element, or deck edge plate, or girder edge frame element. So I'm going to go over this part, and then you move over to analysis part. So generally in bridge engineering, we have the static load analysis and a moving load analysis. So static load analysis, I'm going to go over the dead load and a moving load analysis. I will show you how you can create the moving load analysis, and how moving load analysis can be worked in MIDAS Civil. And you do the like design check such as flexure strength or shear strength or constructability or serviceability in MIDAS Civil, and you can get the Excel report. So for the modeling part, your concern might be you can create a, usually you create a eye girder, but also in widget, as you can see, you can create the eye girders and top girders and box girders, because in widget we have options. So before you jumping into widget, you need to create sections for the top, box, or eye girders on here. So for the steel module, we can handle the three different the girder types in Wizard. And modeling types, depending on your depth of your project. Like if you need to the model a bridge with a plate element, you need to use our plate for the girders and a deck. Or if you just do the like a design, you can use our frame, and depending on your like a level of the project, you might use a deck as plate and girder as frame. So in the wizard, you can create the different a bridge with a different element, such as plate or like a frame or combination of plate and flame element. Now I'm going to briefly show you how you can use the drawing program for bridge modeling in MIDAS Civil. So here, as you can see, I already imported material and a section property, and then I go to import, and you can see the AutoCAD DXL file, but you can also use the MicroStation, and I import the DXL file, and you can see first there is a girder and bracing. I will just import the girder first. Here you can define the material and a section property, and hit apply, and you can see some of like a flared bridge. So when you have the flare bridge, you can just draw the line, and you can define the material and section property, and you can get the like a girder layout from here. But if I just specify some of the portion of the bridge and click activate icon, and when you rotate a little bit, you can see there is no cross frame information on here. It only like activate the girder portions. So now what I'm going to do is I'm going to import the cross frame line information from the drawing program. So it's the same. Now I'm like import the bracing line information, and define the material and section as an angle section. I define and hit apply, and it takes a little bit time. And then you see the cross frame layout on here. So from here, I will just specify some of the portion, and I'll click activate icon. You can see like irregular cross frame layout on here. So if your bridge is very, if your exterior girders are flared out, you can use drawing program. You can draw the flaming plan in your drawing program. It doesn't matter with a MicroStation or AutoCAD. All you have to do is you can save the file as a DXL file, and then you can import the lines. And of course, if you have the curved line, you can import that curved line. What you have to do is you have to break down as a polyline, and you can import the line information into MIDAS Civil, and from there you can define the material and section properties. And if you have if your girder has a different sections along with the longitudinal directions, you can have a multiple like layers, and so you can import each layer one at a time, and from there you can define the section and material properties. So if you have the frame plan for your bridge, you can create a bridge model really easy and really fast. The next step is when you run the analysis, you're gonna have a different result values at depending on the construction stages. So in Wizard, you can contain the construction stage analysis informations, and then you can create a envelope. You can have the load combination on here, and also this one is auto generation of functions in here. And also you can see you can modify the load factors on here, and you can get the envelope on here. And for the design check output, you can have a 3 different format. The first one is a table format, and it says the sections, quarter sections, and those are satisfied with H2 LRFD or not. and you can see the capacity versus demand curve. And finally, you can get the Excel report. So more specifically, after you define the design parameters such as umbrage length or like shear connectors, like properties, transverse stiffness, longitudinal stiffness, or like longitudinal steel reinforcement, and you can get the those like a strength limit state, service limit state, and fatigue limit state, and you can see some of the equations are written on here, which means you can check whether your the design goes well or not, and you can see the OK or NG like a word on here. So you can get this Excel report after you define the design parameters and then run the design check, and you can get those like Excel report. So far, I just go over the big picture of the steel composite girder bridge. So next thing is I'm going to go over the steel a little bit, the steel composite bridge wizard a little bit, and then I will just move to like more like the questions you guys throw away, and yeah, and I will wrap up these sessions. So the first thing I want to go over is the wizard. So this bridge model is created by the steel composite girder wizard, and you can see the steel composite bridge wizard on the structure tab, and I'll click the steel composite bridge. And these are the you can see that this interface at first time. And first, like I said, you can create the different sections on here: composite steel eye, box, and top. So before I jumping into wizard, I want to talk a little bit about the girder sections. So go to property, and when you click the section property, and you can see the sections I already defined on here. This is the deck and girder portion, and you can see the angle sections and WT sections and a different girder sections on here. And once I click add, you can see some of tab for the other bridge sections. But today I'm going to go over the composite section on here. So here you can see the steel box, steel eye, and steel top, right? So this one has two different types. So first one, type 1 means your effective deck width. If you're like a bridge, deck is symmetric with respect to a z-axis on here. You can use a type 1. But if you have asymmetric like a deck with respect to web portions, you can use a type 2. So the last year we have only one type 1, which is the deck width should be symmetric with respect to web portions. But right now you can create the asymmetric effective deck width with respect to web portions. So this one also can be possible at the box sections, as you can see on here, and for the top sections as well. So on the section data dialog box, you can create your girder sections, the box, eye, and top girder sections on here. And more thing about this section, the girder sections, I need to point out the multiple modulus of elasticity. So for the short term and long term, you need to consider the modulus of elasticity. So you can get these values. I know some of you guys, if you use just a normal like a concrete density, you don't really need to calculate these portions. But once you click the select material from DB, and you can see the concrete material, and I just select the deck portions of material property and section for the girder. If I just, for example, if I just use this one and click OK, and you can see those are automatically calculated on here. And then you can just enter such as 3M modular ratio 24 on here. And when program going through the construction ability, it will consider this like a multiple modulus of elasticity on here. And then when you go to like offset on here, which means you can specify your nodal locations. So like here, offset is a center to top, which means you can see the red dot on here. So this beam, two beam elements has a two node and one element. So this node represent the like a beam element for the girder sections, and you can see the like center to top, and you can see the nodal location is located on here. So depending on your project and depending on your the modeling part, you can change your like nodal locations in the sections. So people usually know the girder section dialog box is only for the dimensions for the sections, eye girder and the deck portions, but also you can specify the modulus of elasticity for the long term and a short term, and also you can change your nodal location as well. And then finally, when you click the show calculation result, which this one show the like the values for the section properties such as area, moment of inertia, a section modulus, those kind of things. This before means is before composite status, and this after means this is after composite, and long term and shrinkage. You can guess like this one. Like consider, I mean, those like different status will, apply to the right timing of the design process. And like, as you know, in one just section dialog box, there are a lot of information contained. And then let me go back to structure part and study composite bridge structure, I mean the wizard. So people usually ask me, does MIDAS Civil simulate the traffic surface lane load through the wizard modeling? So in order to apply the traffic surface load, you have to model deck as plate element. So here modeling type is R-frame, which means your like deck portion is modeled as a frame element. But if you use the all plate or deck as plate, girder as frame, your like a deck portion become the plate element, which means you can use the traffic surface lane load on here. So if you guys want to use the traffic surface lane load, you have to model this bridge as a R plate or like a deck as plate, girder as frame. And people also ask about the how you can define the baseline locations over a bridge. So like we have a different terms like for the baseline, we call the reference line on here. So you need to specify where is the your reference line is. So here layout offset means the distance between the center line of the deck and reference line. So which means here it says 0, which means your reference line is located at the center line of the deck. So this one like influence your the girder locations and girder variation, because if your bridge is curved bridge, your inner girder line length and outer girder line length are different, and you need to specify what is the reference line, and you can just use the information with respect to your reference line. So such as here, so I specified span informations. So here it has 3 spans. The first span contains the 80 feet, and second span has 100 feet, and third span is 80 feet again. So I put the layout of the equals 0, which means the reference line is located at the center line of the deck. So this span length are the 80, and the second span on here is the 100 feet, and third span here is 80 feet. But if you just put your reference line at the edge of the deck, your span information must be larger than the 80 or 100 feet. So by just specifying your like reference line, you can create your bridge model with a shortened information. I mean, given information, even if your given information is not enough, you can create bridge models on here. And then the support skew angle, if you put the support skew angle on here, which means you have the one uniform support skew angle throughout the entire bridge. But if you just check on this advanced box, and you can specify each different support skew angle on each different support lines. So, and also this radius is 500 feet. So this one, the distance is from the center of the circle to the reference line you defined. So this one has a 500 feet, the radius. And next week, I'm going to go over the multi-curve. So next week, I'm going to explain what each terms represent on here. And I will just make like a couple of like examples and let you understand how you can use the multi-curve options on here. And those are Girder types from the span informations, and those are just for the framing plan you have. You specify the span information and total deck width, and your support skew angle, and you specify your baseline, and underneath of these portions, you can see the boundary. So in the widget, you can create a bridge model with a substructure or without substructures. But most of you guys have question about the bearing properties. So what does mean is you're like a support superstructure modeled, as a gutter sections and deck sections, and you need to connect your superstructure to substructures. In that case, in the rear bridge model, you have the bearings. So how you can specify your like a bearing properties on here. So first over here is it says Kx is a vertical and Ky is a transverse and Kz is a longitudinal. So people can now understand this part because the global coordinate in MIDAS civil is x is generally, as you can see, is a longitudinal directions, and y is the transverse directions, and z is a vertical directions. But let me just pull up the one example and I give you explanation, idea how you can define the elastic link local axis on here. So we have a different like coordinate system. So generally when you create a bridge model on the model view, if you use a plate, if you just use a beam element, you just follow the global coordinate system. But if you use an elastic link has their own like elastic link local axis, and as you can see, here the z-axis is actually the longitudinal direction, and y is a transverse direction, and x is vertical directions. So elastic link has their own like a local axis. So this widget create a bridge model automatically with the information you defined. So I want you to understand why this x-axis is a vertical and the z-axis is a longitudinal and y is still transverse directions. So as you can see, the x is a vertical and y is a transverse and a z is a longitudinal. So like one more question about the stiffness. How much you have to like use, I mean, what is the proper number for the stiffness of the elastic link? So if you are like a bridge is, I mean, the bearing has the resistance on the like a vertical direction, which is kx, you can just enter these numbers. You can just enter the very huge numbers on here, and even there is a huge load is transferred to the substructures, which means it can transfer the load to the substructures. So you can enter those numbers on here. Or if you have like a longitudinally, if your bearing does not resist uh, the load at the longitudinal direction, you can just enter a 0 on here, which means it cannot transfer the load to the substructures with longitudinal directions. So for the elastic link, you can have the like reactions at each like elastic link, and you can design your bearings from there. And you have to tell the program where is the fixed support. So I said here pier 1, which means at the pier 1 on here, you can see the abutment 1, pier 2, abutment 2, which means from the left side here, very first support line, which represent the abutment 1, and the second one is a pier 1, and third one is pier 2, and the last one is abutment 2. So you can specify the support local, I mean nodal local axis. You can see the tangential and radial. So you can just refer to online help menu by pressing F1, and you can see how you what is the tangential directions and radial directions for the fixed support. And the next thing is the section tab, and you can see the deck thickness, and you can see hunch height is grayed out on here. So you can see when you are modeling type is R frame, your hunch height is grayed out on here because you already define the hunch height on girder sections on here. So capital H and small h represent the hunch height. So you already defined your hunch height on here. So R frame, you don't really need to define the hunch height again. But if you change your modeling type as all plate, and when you go to section, there is a hunch height is not grayed out, which means it's activated. Because when you select the R plate element, so in that case, like deck and the girder sections like individually created by the plate element. So two different like sections, I mean for the deck and the girder. So from there, deck and girder section, you need to bind them as a rigid link. So you need to specify the hunch height for the two different, I mean individual like element. But when you use the girder sections, this one contain the effective deck width of the deck and girder sections. So here for the beam element, you don't need to specify hunch height again. But for the plate element, you need to tell the program what is the hunch height, because there is some gap between the deck and a girder. Two different like girder and deck are modeled as a plate element. So there will be the rigid link or elastic link will be used to bind two different like element. And then here is a number of girders. Here has like a 4 girders, as you can see. Girder 1, girder 2, girder 3, and girder 4. And girder offset means here is a negative 13.5 feet apart from the baseline. So we specified baseline as a reference line, I mean the center line of the deck. So girder number 1 is negative 13.5 feet apart from the reference line, I mean the center line of the deck. And girder number 2 is negative 4.5 feet apart from the baseline. So you can specify the location of the different girders, girder 1, 2, or girder 4. And here you can specify what is the material of the each like a section, such as a deck and girder and bracing. And this one is like the transverse element. Here, the transverse element, for the frame element, when you use our frame, you need to use the 2D collision analysis. In that case, you need to create like a dummy deck, which is weightless, but it contains the same stiffness of the concrete. So we can transfer the load with a transverse directions. Because just girder, it only consider the longitudinal directions. So in order to transfer the load to the other girders, you need to create the transverse deck element. So Wizard will create the transverse deck element for you, but you need to tell the program what is the transverse deck element spacing. So usually we recommend you to use a 5 feet or 10 feet. And then for the bracing details, so here once you click the bracing details, you can create those like X brace or V brace, those bracing sections for here. So when you click the type A, I already created the sections. So if your breach, type A, like a cross frame does not have the top portions, you can just check off this box and you can create a brace and a bottom portion. And those two boxes represent like a distance between the very top flange to the center of the angle sections. So from here to here is for the top, and from here to here at the very bottom flange, which is the distance. Like you can enter those distance information on the bottom boxes on here. And when you go to type B, you can see I put the WT sections at the top portions, and I use the same bracing informations such as X on here, and I put the angle section at the very bottom. So here is the different spacing informations. If you are cross frames has such as first span is like a 5 feet. Spacing is 5 feet. You can enter the 5, and second span, if you have the 6 feet, you can enter the 6, and third span you can put the, if it is a 5 feet spacing, you can put the a 5 on here. So this one is used by the distance information. And if you are if you have the division information such as the very first span, if you have 7 divisions, you can just select the division per span, and you can just put the a 7 comma something, which separate your span, the a first and second span. So you can enter those cross frame layout that way, and also you can specify your cross frame angle types. So if you select the skew angle will follow the skew angle you defined on the layout tab. And if it's a perpendicular, your cross frame will be a perpendicular to your baseline. And also you can put your own skew angles for your cross frame. As you can see, you can just click the user define on here. And if your cross frame layout is a different, different gutter by gutter. As you can see, gutter between gutter number 1 to gutter number 2, you can specify different cross frame layout on here. And gutter number 2 to 3, you can specify a different cross frame layout on here. And also each support lines, support 1 to support 4. Support 1, which means is abutment 1, is a very left side. Support 2 is pier 1, and support 3 is a pier 2, and support 4 is abutment 2. So on each above the support line, you can specify your cross frame information on here. And the gutter informations, as you know, a total the gutter length is 260 feet. So you can segment your gutters variation with a different gutter sections. So you can see a section 1 and section 2, section 1 again section 2. You can see specified from where to where this section 1 will be used. And also, if you once you complete the and fill up those boxes, and this one is a Girder 1. And in the Girder, if your Girder 1 and a Girder 4, those are like exterior girders. Girder 1 information has same contain the same information as with Girder 4. You can just click the copy current Girder data to other girders, and then you can move on to Girder 4 on the selected list and click OK. And same information is copy and paste on the Girder 4. So you can put those Girder information on here, Girder 1 and Girder 4, if the exterior girders are the same Girder sections along with the longitudinal directions. You can copy and put and on the other Girder sections. And the last one is the construction stages. So first, these are the default setting. So this one just simulate the general construction stages from the construction stage 1 to construction stage 4. So stage 1, you can see the girders and bracing is activated. If you have the substructures, substructure is activated first, and then girder and bracing is activated. And the second thing is the wet concrete load for all deck is activated, and the next step is all deck is activated, and stage 3 after composite, and stage 4 there is a long-term effect. So as you can see here, wet concrete load and after composite, and also there will be like a DC to DW, which means dead load of the component and attachment, and dead load of the future wearing surfaces load. Those are used in the construction stages. So how you can enter those dead load informations, which is governed under the load tab. So when you go to load tab, you tell the program each load information on here. So first, B1 to B5, this one represent the location of the each dead load. So B1 and B5 is the barrier load, and B3 is the median strip load. So also you can put the additional load if you have the ramp at the edge of the deck. You can also put the check on this box, and you can tell the program what is the load information on here. So let me just go over the dead load. So for the wet concrete load, if you know the weight density for the wet concrete load, and if you know the thickness, you can enter those numbers on here, which is a DC, dead load of component before composite status. So, and then after composite, the deck and steel become the A perfect sections, and you pull the a barrier load or a median strip load, and then after that you put the wearing surfaces load on here. So those information will be transferred to the construction stages, and when program create the a construction stage informations, those load information also transferred to the construction stages. So after you create a bridge model through the widget, you can check each a moment shear and stress values depending on your different construction stages as shown here. And also for the live load, you specified which code you want to use, H2LRFD, and click. And then you can define the a traffic line lanes on here. So here from the very left edge, you can specify the distance from here to here, which is the center line of the traffic line lane. You can give the offset, and you can specify the longitudinal traffic line lane on here. And for the defined vehicles, as you can see, once you click Edit Standard, we have a good library on vehicle informations. So H2LRFD load, and then you can see the HL93 trucks, HL93 tendons, and if you need to do the load rating, we have also the legal and permit load, and each different DOTs, we have a specified vehicle information on here. And then if you cannot find the vehicle information on our vehicular information, I mean the defining the vehicles, you can like add your like a truck and a permit truck, like information you can create on here in MIDAS Civil. So this load tab information and construction stage information has some interaction between there is some interactions, and also if you wanna like do the like deck polling sequence, you can also do on here. You can give the order to the program which like a deck portion is activated first and which portion is activated later. So, and then also here reinforcement. When you see the like reinforcement, so under like negative moment regions, the at the like top portions, if there is only like concrete, it cannot resist the tensioner moment, right? So in that case, you put the like steel reinforcement on here, and then program when you run the first like analysis, you can just consider this steel reinforcement part at your like result values. So people does not know these functions. So like if you have the if you want to consider the steel longitudinal reinforcement, you check on this box and put the like your steel like reinforcement on here, and then before you run the analysis, go to analysis, and you can see the main control data icon on here. And then you have to check on this box, consider reinforcement for section stiffness calculation. So which means this one, consider the steel reinforcement under the negative moment. So these are the like wizard, and as you can see, I just created this model from the wizard, and let me just activate the section thickness, and you can see this is the steel composite girder bridge wizard. This is our frame, and then let me just change the colors on here to distinguish the different girder sections at different locations. So I ran the analysis. So the next thing is I want to go over. Its time is already like 15 minutes past. Okay, so let me just go faster. I will go over the result values depending on the construction stages. So first, once you run the analysis after you the create a bridge model through the wizard, and what you can do is go to analysis and click the perform analysis, or you can just see the small icon which represent the perform analysis, or press F5 button on your keyboard and you can run the analysis. So let me just like go to wizard, and this one is our frame model. So let me just show you how you can check the like a beam diagram on here, and you can see like different construction stages from stage 1, and then let me just check the MOY, which is like a moment values at the strong axis, and hit apply, and you can see the like a moment values along with the longitudinal directions, right? This one is only like a steel and a bracing information is activated on here, and stage 2-1, which means there is a wet concrete load is applied on here, and stage 2-2, give me a second. So at this stage, at this like the status, I just use the deck polling sequence. So around the negative moment region, around the negative moment region, I activate the deck portion first on here. So go to result and beam diagram, and hit MOY, and you can see the like moment values at different construction stages on here. So these are the way of the check your research values. And this one, I forgot to turn on the legend. So you can, like see what is the maximum and what is the minimum for the moment. And also for the shear forces, you can just change the F of Z on here, and you can check the like shear forces values along with the longitudinal directions without different construction stages. And then let me just going over the moving load analysis a little bit. So for the structures, you can see the like load informations, and you can you define the traffic line lane. Where is a longitudinal traffic line lane, and you define the vehicles. So from there, you need to create a moving load cases. So how you can specify, how you can create your moving load cases. So go to moving load, because I already defined the traffic line lane in the widget. It's already in the model informations. So under tree menu, and when you click the display, and here is a longitudinal traffic line lane. It's located on here. The traffic line lane first, and click display 2, and this second lane on here. And then I already defined the vehicle as well, right? And the third thing is you have to create the moving load cases. I already created on here. So there is so if you want to bind the two different, if you want to make a one group for the two different vehicles, such as here, when you click the vehicles, here is a HN93 tendons, and here is HN93 trucks. And if you want to make this one as a one group, you can just click the vehicle classes and click add, and you can make the one group. And then when you go to moving load case, you can create the moving load case, which means if you just make the two different vehicles as a one group, this one group will floating above the deck at the same time, and it will give you the worst case scenario on here. But if you want to just create your moving load cases vehicle by vehicle, you can just select the this tendon or truck on here, and then here it only has a tendon, but here you can create one more vehicles. And this one is a minimum number of the loaded lane. Really, this truck at least will floating at the one lane, and the maximum will be a 2 because it has 2 lanes. So I have a 2 sub-load cases, and independent means it will give you the program will floating those 2 different vehicles individually, and then it will give you the worst case scenario, and so among those 2 vehicle sub-load cases, among those 2, one will be picked up for the your moving load cases, for your research values for the moving load maximum or minimum. Or if you just select combined it, which is just like the envelope, you can just program will give you the research values, those 2 like a truck combined it effect for you. So depending on your project, depending on your study, you can create a moving load case as much as you want on here. So those are the moving load cases, like a very basic knowledge in the MIDAS civil. And we go over the a beam diagram, and such as shear and moment values, and also you can get your support reactions at different let me just turn on the values on here. A different depending on the different construction stages, and you can also get the deformation values on here. So for the analysis part, before you moving on to design process, you can check your analysis values, and those like analysis values is enough to use for your design process. If you don't want to use our design process, what you can do is you can just use those like values. I just show you the just a diagram, but also you can create table information on here, like and I will just select the dead load and stage 1 and click OK, and you can get this table information on here. So like with a table information or like graphical view, you can design your program and design your the bridge from this like a status. But after that, we help you to get a design value, design output values when you go to design, and once you set up those like design parameters, you can get the design output values like I show you on the slide. But let me go over more questions from our clients. So far I show you the R-frame model, but you can also create your bridge model for the plate element. So as you can see, those like a deck portion and a gutter portion is created by wizard, and you can see there is some like a thickness on here. So this like deck portion and like a gutter portions program, once you like define the section property at the section dialog box for the gutters and the effective deck width of the deck and thickness and hunch height, program will automatically create a bridge model, I mean plate element for you, because basically plate element contain the 4 node and one surface. If you just imagine, if you just create a bridge model for the plate element from scratch by just taking all the coordinate and putting on your FEM program, it will take a lot of time. But based on the information you specified in the widget, when you just select the R plate or deck as plate or gutter as frame, you can get the A bridge model with a plate element really easy, and it doesn't take a long time. You can just fill up those informations. So I know last year we talked about the R-frame model a lot. So today I'm going to briefly go over the plate element model as well. So let me just okay. So this is the plate element, and as you can see, when you go to widget, and you cannot use the beam diagram anymore because these are not, those elements are not beam element. So what you can do is you can just go to widget force diagram and click apply. So this one is for I'm going to check the moment values as strong axis on each gutters. So give me a second. I think it take a little bit time because I open up the like multiple MIDAS civil program. So as you can see, you can get the like a resultant like a moment forces on here. So which means you have like two different like elements. I mean, largely you have the deck portions and a deck like a gutter portions. So and those like deck and a gutter like bind by rigid link. And when you just like a like a program calculate the moment values, you program need to consider the deck portion and gutter portion, and it will give you the resultant like forces like this way. So even you use the plate element, you can get the those like resultant by using the resultant like moment like functions. You can get the moment values really easy. And you know, like the reason you use the plate element, if your bridge is very complex, um, and if you need to use the finite element knowledge, you need to use the plate element. So in that case, MIDAS will help you to create a model really easy and fast, and then it will MIDAS is ready to, you know, like give you the result values with a, you know, easier like a method, easier like, you know, manners. So and then you can see those are the different from the R-frame model. And also for the stage 1 to stage the last stage, you can check your like a moment and forces values. I mean the shear forces values and also stress values as well. It take a little bit time. So as you can see, this one only like I activate the steel portions, which means steel girders and bracings, and you can see those are like moment values depending on the different construction stages. As you can see, by using the plate element, you can, you know, like use these values with a like easy manner. And last thing I want to cover is the design process. But beforehand, let me talk about the moving load case more. So this is the like a frame element. I just define it on here, and when you go to moving load, give me a second. And one more question about from the our clients. If you need to get the concurrent forces and stress, I mean this. What does this mean? Is you know, why MIDAS will run the moving load analysis, and MIDAS Civil, when you like run the moving load analysis, it like generate like a, you know, numerous vehicle floating cases. So that's why when when you probably you know that when it MIDAS Civil move on to moving load analysis, it take a little bit time, more than like just a static load analysis, because it generates a lot of like a moving load cases to find the worst case scenario. So also when you generate the many like different like moving load cases, you can just think you're like vehicles just floating on this deck, feet by feet, or like, you know, 0.5 feet by 0.5 feet, and this element contained all the like result values on here. But like when you perform your design, you don't really need to use the like a maximum, all the like a maximum like a value, such as you don't really need to use the maximum moment values, maximum shear values, or like, you know, maximum like a stress values. So when you have the maximum moment values, and at that moment the corresponding like a shear forces can be different. It shouldn't be like, you know, like a maximum shear forces. So which called concurrent force and stresses. And once you just select this option and run the analysis, and you can get the concurrent forces and stresses. So how you can get those like concurrent forces? Let me just go to result values, and give me a second. And when you go to forces and a beam diagram, and then I will just create the like the structure values with the table informations, and structure groups, and click OK. And you can see like a shear values and Z values, and like a moment, and like this one is for the the strong axis, and this one might be the weak axis. So those are like show you the like a maximum values. Like consider all the like moving load cases generated in MIDAS civil. But if you want to see the concurrent forces, what you can do is you can just right click on the table and you can see the view by max value item, and what like item you want to use for the maximum, but other like forces is just like the forces at that like when the maximum moment values generate. So this like MIDAS will contain all the moment of the moving all the cases. So when you see, as you can see, I just check on the moment dash y, which means at the strong axis, the moment values, the maximum moment values created. But other shear forces or shear G or like the weak axis moment is not the maximum. It's like the values on here represent the when moment y generate at that moment. So check on the moment y, and I wanna moving load case you wanna check. So I will just select the very first the load combination, and when you click OK, and you can see the maximum moment values, but at that moment y value generate, you can get the those like other like structure values on here. And when you use these values for your design will be less conservative than just using all the like maximum values for the shear y, shear g, or torsioner, or like a moment at the weak axis. And so today I just compare the I just briefly like give you some like a general idea how you can use MIDAS Civil, how you can use MIDAS Civil for your steel girder project. So for the R frame, you can use the design process, and if you're doing the load rating, if your bridge is very complex, if you need to use the like a plate element, you can use the MIDAS Civil, and you can create the plate, a bridge model with a plate element using the widget. It's really easy and handy, and it will get to the point really fast. And then, our frame and our plate element, you can get the widget values with a proper manner in MIDAS Civil. But when we do the design process in MIDAS Civil, you can only use the all frame element. Through the all frame element, you can go through the like a design process. So if your bridge is contain the like plate element as girder, a girder as a plate element, you cannot run the design process. But if you use the beam element for the girder, you can do the like design process. So when you go to design, and here this one, you tell the program what is the parameter for the design. So like a design parameter, and you can see some of the like strength resistance factors. You can specify, you can modify those strength resistance factors. And then like a longitudinal reinforcement, you can also put the like longitudinal reinforcement on here. And those like design parameters, once you define those design parameters, and once you run the design, and you can get the Excel report, and you can get the design result tables on here. This part, I will go over this part later on, like next week, or like last week of this webinar. But R frame, by using the R frame element, you can get the design output. You can get the Excel report as I show you on the slide. So yeah, today I just want to give you some like a general idea how you can use MIDAS Civil for your steel composite girder project. But from next week, we will go over the like step by step, like we're gonna like give you a more specific idea how you can generate the model, and how you can review the like result values, and how you can do the design process for the girders and substructure and superstructures. So yeah, please join our the next week webinar. I'm going to get into more details about the steel composite girder bridge. And this week, Wednesday, I'm going to go over the like a cable stay bridge as well. So thanks for coming here today. And if you guys have any questions, just let us know through our email or if you have questions, you can just send me an email as well. So yeah, again, thanks for coming here. I will just finish this session right now, and I have some like question list on here. If I can, I will like reply back your questions through your emails. Thank you very much, and have a great day.